The topic is dimensional analysis. In dimensional analysis, these are some of the main topics which comes under this unit. At first, we will see the introduction of dimensional analysis. It is a mathematical technique used in research work for design and conducting model tests. It deals with the dimensions of the physical quantities involved in the phenomena. It helps in testing the dimensional homogeneity of any equation of fluid motion. It helps in deriving equations expressed in terms of down-dimensional parameters. It helps in planning model tests and presenting experimental result in a systematic manner. So the primary are fundamental quantities and secondary are derivative quantities. These are the main two topics which will mostly helpful in identifying the dimensional analysis. The various physical quantities used to describe a phenomena can be described by a set of quantities which are dependent of each other. These quantities are known as fundamental quantities. For example, mass, time, length, temperature are the fundamental quantities. And the secondary and the derivative quantities are all other quantities such as area, volume, velocity, acceleration, energy, power are termed as the derived quantities or secondary quantities because they can be expressed by using the primary quantities. This is the name of the quantity and the symbol, unit and dimensional table. At first, for area, the symbol is A and the unit is meter squared and the dimension is L squared. Similarly, for volume, the symbol is V, the unit is meter cube and the dimension is L cube. Accordingly, for angle, velocity, angular velocity, speed, acceleration, gravitational acceleration, discharge, mass density and specific weight. For these quantities, the symbols, unit and dimensions are given. For example, the discharge Q, it is meter cube per second. For dimension is L cube T power minus 1, otherwise L cube divided by T. Similarly, force, dynamic viscosity, kinematic viscosity, shear stress, surface tension, pressure, modular elasticity, modulus of elasticity, bulk modulus, work done, torque, power. For these quantities also the symbol, unit and dimension are given. Let me take the bulk modulus. The symbol is K and the unit is Newton per meter squared or Pascal, and the dimension is M, L power minus 1, T power minus 2, otherwise M divided by L divided by T squared. So this will be much helpful while solving a dimensional problem. So let me take this problem. Determine the dimensions of the quantities given below, which is velocity, density, angular velocity, angular acceleration, discharge, kinematic viscosity, force, specific weight and dynamic viscosity. So we know that the formula for velocity will be distance divided by time. For distance, the dimension will be L. For time, the dimensions will be T. So L. So moving T from below to top, it will be take T power minus 1. Similarly, density is equal to mass by volume. So mass, the symbol is M. Volume, it will be L3. So it will be M L power minus 3. And angular velocity, the formula is angular displacement by time, that is 1 by T. So T power minus 1. So angular acceleration, it will be angular velocity divided by time, that is 1 by T into 1 by T, that is 1 by T squared, and it is T power minus 2. Finally, the discharge, that is A into V, A is equal to meter squared, V is equal to meter per second, and will be meter cube per second, that is L cube T power minus 1. And dynamic viscosity, tau is equal to mu du by dy. So we need to find out the value of mu, that is tau divided by du by dy. For shear stress tau, it will be m L power minus 1 T power minus 2, and du by dy will be T power minus 1. So resolving this, we will get m L power minus 1 T power minus 1. Here we can say that for shear stress, it is force by area, that is force ml T power minus 2, for area L power square, that is m L power minus 1 T power minus 2, which will be applied in the tau value. And for similarly du by dy, so u it is L T power minus 1 and y it is L, so resolving this we will get T power minus 1. This is going to be applied in dynamic viscosity formula. For force, the formula is mass into acceleration. So mass, which is kg, and acceleration meter per second squared. For mass, for kg, the dimensions will be m, and it is L T power minus 2. And kinematic viscosity, the formula is dynamic viscosity by density, which is m L power minus 1 T power minus 1 by m L power minus 3. That is L squared T power minus 1. And finally, specific weight, the formula will be weight divided by volume, that is n divided by m cube. And for the sorry, and for dimensional applications, it will be m L T power minus 2 divided by L cube, which will be m L minus 2 T minus 2. So that is all. And next thing is dimensional homogeneous. An equation is said to be dimensionally homogeneous if the dimensions of the terms of the right hand side and the left hand side will be equal. For example, v is equal to root of 2gh. So the v, which will be given meter per second, that is L T power minus 1, and g it is L by T square, and h is L. Both applying in both directions. For v it is L T power minus 1 and root of 2, and g will be L T power minus 2 and h is L. By solving this, right hand side will be equal to left hand side, that is L T power minus 1 is equal to L T power minus 1. Methods of dimensional analysis. For solving the dimensional analysis, two methods are employed. One is Rayleigh method, another is Buckingham method. Rayleigh method, which will give the values of A, B, C, are obtained by comparing the powers of the fundamental dimensions on both sides. Thus the exponent is defined by dependable variables. If the number of independent variables becomes more than 4, then it is very difficult to find the expression for the dependent variable. And for using this Rayleigh method, the problem will be find the expression for the power developed by a pump when P depends upon head H, the discharge Q, and specific weight W of the fluid. For P is equal to F of H Q W. Removing the functional value, we will give the constant value of K and put power on each variables. For H Q W, apply the fundamental variables. For P it is m L square T power minus 3. For H it is L, Q is equal to L cube T power minus 1, and W m L power minus 2 T power minus 2. Now we equate the powers of MLT from both sides of the equation. For powering the m, for power of m it will be 1 is equal to C, and for power of L it is A plus 3B minus 2C. So resolving it will be give the value of 1, and for power of T it is minus 3 minus B minus 2C, and resolving this we will get the value of P. So substituting these values, we will get the equation as P is equal to K H Q W. So thank you.